In your exam, if you take, I gave you a problem, exactly this problem. This is the problem I asked you to solve for it. In fact, both versions of the problem was from this problem, maybe with a slight complication with an axial load over here. I'm surprised that majority of the students left the exam blank. Blank. You return to me blank papers without even attempting to solve anything. And especially those students who returned a blank paper, you cannot have a makeup exam. If you think that I will give you guys a makeup exam for being so irresponsible, I'm not going to reward it. Okay, so I will discuss with the department and then come back to you regarding makeup exams or for those who have already taken the exams. On the other hand, students who were absent with valid excuses and doctor's certificate provided to me, they will have the makeup exam maybe this week or next week. I'm not sure. I will set up the paper and then we will have a makeup exam. Okay. In addition to that, the makeup exam for those who were absent, I am going to make it tougher. So I'm not going to reward anybody in any way unless you have worked for it. Okay. Any other doubt? So again, please send a message. Those who are continuously being absent for the class, do not expect me. I'm going to put a penalty for them. So I'm going to increase those who participate, those who attend the class from today. I will give them 10%. Those who do not participate, 5 to 10%. Those who do not participate, they will lose this grade. Okay. So let's continue from last class. In the previous class, we went through a problem on fatigue. The fatigue problem involved, if you recall, identifying what is the load line. The load line in this particular case was horizontal, unlike the radial load lines. If you recall again, we had a horizontal load line and we figured out what is the factor of safety by finding what is the mean stress at these intersection points between the yield line and the Gerber curves. Okay, so in this problem we did not specifically go through on how to calculate the number of cycles to failure because it was not required. In all these three cases, A prime and A double prime, we are well inside the failure envelopes, especially the fatigue failure envelope, and therefore the life for steel specimen will be infinite. So I did not predict what is the number of cycles to failure. On the other hand, in this particular problem, we are going to calculate what is the number of cycles to failure. So let's read through this problem. Before that, just give me one moment so that I can connect my iPad. Okay, so now connected. So let's read through the problem. A steel bar undergoes a cyclic loading such that the maximum stress is this much and the minimum stress is this much, you are directly given what are the stresses, maximum and minimum. For the material, again, the material properties are given as ut value, as y value, and a fully corrected SC value is also given along with fatigue fraction F is equal to 0.9. So this simplifies our calculations greatly. Estimate the number of cycles to failure, to fatigue failure using modified Goodman criteria and Gerber criteria. Okay. So how do I calculate the number of cycles to failure? First, what is the data that is given here? Sigma max and sigma min. Okay. So I'm going to write sigma max is equal to 60 and minus 20. Minus 20 kPSI. Okay, so here, how do I calculate the amplitude? How do I start? First, I need to calculate the amplitude of stress. Before we calculate the amplitude, sorry, should be this one. We do not have any stress concentration factors here in this problem. We are not given any geometry. We are directly given the absolute maximum values here. So we can go ahead and calculate the amplitude. Sigma max minus sigma min over 2 with an absolute value, because sigma amplitude is always positive. 60 minus of minus 20 becomes 60 plus 20 is 80 by 2 becomes 40 kPSI. Let's calculate the mean stress. The mean stress is sigma max plus sigma min over 2 without any absolute sign. It can be positive or negative. So 60 minus 20 is 40. 40 over 2 is 2 kPSI. So clearly this is mean stress is not zero. It is non-zero. So it is not a completely reverse loading. How do we proceed? We are asked to use modified Goodman criteria. Okay, so what is the modified Goodman criteria? So let's see if I can open up the textbook and see the corresponding tables so that we can refer easily instead of going front and back on these slides. I'm going to go to the table showing the Goodman criteria. Okay. Okay, so we have it here. The first one is the Goodman criteria. Okay, so how do we use this table? Let's go back here. What we are asked, estimate the number of cycles to failure. So first we need the equation that gives us what is the number of cycles to failure. So let's go back before going to the Goodman criteria and look at the equation for number of cycles to failure. Let's see here again. We need to go a few slides back, and this is the equation. So let's write down the equation. The number of cycles to failure is going to be sigma reversible over, if you look at the equation over here, so SF will be sigma reversible over A raised to the power 1 over b. And we have the equation for A. A is given by FSUT square over SE value, and B is given by 1 over 3 minus 1 over 3 log base 10 It looks like something is wrong here. Just 1 second. Okay. Okay, log base 10 FSUT over SE. So these two quantities we can calculate because F we are given in the problem. And let's see here, F is equal to 0.9 times SUT value is given in the problem again, 80 kpsi. SE value on the other hand is given 40 kpsi. Okay, so let's calculate. Let's open up a bracket, square over something. 0.9 times 80. So that gives us, what is the A? 129.6. Okay, then the other one, B is equal to minus 1 over 3 times log base 10. I think 10 it should be. Let's just make sure if the formula is base 10. Okay, so here this comes from the SN diagram, definitely. So it should be base 10 since it comes from the, yes. So all these formulas are based upon base 10. Yes. 0.9 times we have SUT here. Let's write down the values before proceeding. SUT is 80 and SE value is 40. So this will be definitely KPSI A, and we can write B value 0.9 times 2 because we have 80 over 40, that is 2, minus 0.0851. B doesn't have any unit, so just let's put it in the brackets. Okay, so we have A and B we should be able to calculate the number of cycles to failure, but then when we see there is sigma reversible term here. How do I find what is sigma reversible? To do that, I have to draw the Hague diagram and figure out what is the equivalent number of cycles to failure. Reversible amplitude of stress, so that I can figure out what is the number of cycles to failure. Okay, so on the x-axis in the Hague diagram, I have the mean stress, y-axis amplitude of stress. So we can draw, let's identify before we draw anything. We want to solve it by Goodman and Gerber equations or Gerber curves. For both the cases, we need the point SE and SUT. Want to draw a straight line joining these 2 points. Okay, so this is going to be your Goodman line, and I want to draw a curve, an ellipse that passes through these 2 points. Let's see if I can draw a curve here. Apparently not. So let me approximate the curve with hand. So this becomes the Gerber curve. Okay, and this is a parabolic. Assume this is parabolic. Okay, and then the black line is the Goodman line. Now, besides this, we need to identify another point, which is the SY, yield stress or yield point on both the axes. Let's assume this is the yield point, and then we have to draw the yield line as well. So we have in the green yield line or Langer line. Okay, so now here we have a couple of intersection points, but before we go there, first we need to figure out where our point of interest is. So we have figured out what is sigma A and B, sigma A and sigma M, sorry, 40 and 20 kpsi. Let's also write down all these yield point values. The yield point is given 65 kpsi and UT is 80 kpsi. Okay, 65. This value is 65. Let's note down SUT value 80 kpsi. Okay, then SE value is 40 kpsi. Okay. So this much is there. We already identified sigma A and M, 40 and 20. So if this is 65, we have to divide it 20. Let's divide the axis. 40, and maybe this is 60, 65, and 80. Okay, so looks almost right. Let's also divide this equally. 40, and maybe this is too close, but assume this is 65 right over here. Okay, so this is 20. Each division is 20, 20 here, 40, 60 here, 65, and 80. The same way 20, 40, assume this is 65, although the distance is not proportionate. Okay, so we have sigma amplitude is 40. Amplitude is 40 over here. We have already crossed the endurance limit clearly, and the mean stress is 20. So let's note down our intersection point is right over here. So we can draw a load line now joining the origin radial load line to here through this point, and that will give us the intersection points. Okay. All right, so now I want to find finally what is the number of cycles to failure. I need to figure out what is sigma reversible. Before we do that, let's try to find what is the factor of safety. To find the factor of safety, fatigue factor of safety to be accurate, we can do it the graphical way. This is the origin. Let's identify our point of interest as A, which is 40, 20. We also need the intersection points in the case of the Gerber curve and the Goodman line. Okay, so to get these intersection points, let's denote them by different letters. So since I denoted the other one by A, I'm going to denote this point by B. And there is also an intersection point between the Gerber curve and the line. So I'm going to put it here and I call it C. Okay. So I can find the fatigue factor of safety according to, let's say first I'm going to calculate it according to Goodman. Okay, is going to be OB over OA. Now what is OB? I need to find the intersection point B. To find that, I go back to the table. Let's see here. This is the fatigue factor of safety formula directly here. I can use this directly instead of doing it graphically. But if you want to do it graphically, you need the intersection point between the load line and the Goodman line. And this is the intersection point. Okay, SA and SM value. So one, I'm going to do it by intersection point, the other method by directly using the formula. So SA, the intersection point is given R SE SUT. So first I need to find what is R. Okay, so I'm going to write R here is nothing but sigma A over sigma M. 40 over 20 is equal to, we have the R value, R times SE times SUT. So R is 2. SE value we already know is, what is this?
Sorry, I'm still not sure about that.
Second.
There's nothing to read.
Okay. 2 times 40 times SUT value is 80 divided by R SUT, 2 times 80 plus SE value, which is 40, gives me the intersection point. 2 times 40 times 80 . 2 times 80 plus 40. So we get 32. Okay, let's say value is 32 kpsi, the intersection point corresponding to point B. SM value is given by SA over R. 32 over 216 kpsi. So from here I can get the lengths OB and OA. OB will be equal to 16, use the Pythagoras theorem, and OA, because this is the point B, you want the length of the hypotenuse. The point B has the coordinates 32 SA SM, so 32 comma 16. So if you look at it, 32 comma 16, sorry, 16 comma 32, the other way around. Sixteen is the sigma m value, 32 is the sigma a value over here. So use the Pythagoras theorem. 16 square plus 32 square, and that's what we have used. O A is going to be, we know the point A, coordinates are 20, 40 again. Then I think I wrote it in the other way. Should have been 20, 40. So we can write it as 20 square plus 40 square. And let's see here, definitely you are going to get a value less than 1. So the numerator we have 32 square plus 16 square. In the denominator we have 20 square plus 40 square. So we get 0.8. Obviously the fatigue factor of safety is less than 1. Implies finite life. So we need to calculate what is the finite life. You can do the same calculation with Gerber equation, and you will find still it is less than 1. You have to calculate. Okay, so We know that we have to calculate what is the finite life. That means I have to calculate, I have to know what is sigma reversible. To know sigma reversible, this is the point of interest. Okay, so first I need to draw a line. Let's see if I can draw a line in different, any other different color. Brown. Okay, so from SUT, in terms of Goodman equation, I'm going to draw a line passing through the red point. And I'm going to let it intersect y-axis at somewhere. So this intersection point over here, this is the sigma reversible. Now, how do I find the sigma reversible? By simply using the Goodman equation. What is the Goodman equation? Go back to the table. We have the Goodman equation here. SA over SE. So we can write it as sigma A over SE. Instead of writing SE, I'm going to replace it by sigma reversible. Why do I do this? Because essentially I want to get the equation of this brown line. Okay, the equation of the line is produced by the intercepts here and here. At this point it is SUT. At this point the intercept is sigma reversible. So I'm going to write it as sigma A over sigma reversible plus sigma mean over SUT must be equal to 1. Sigma A and M values are known. Sigma A is 40. Sigma reversible is unknown. Sigma mean value is given as 20. Where did we get this 40 and 20? These are the calculations we have done for our case. Okay. Remember, this brown line passes through the red point whose coordinates are sigma m equal to 20, sigma a equal to 40. And we want to get the equation of that brown line, and that's what I'm doing here. 20 over SUT value is 80 is equal to 1. If you are asked to take a factor of safety, then we have to divide by n. Okay, but here we are taking n is equal to 1 and doing the calculation. Okay, so what is sigma reversible? Rewrite the equation. You are going to get 40 over, taking this to the other side, 1 minus 20 over 80. Okay, take this to the other side, bring it to the denominator, take sigma reversible to the numerator on the right hand side, and this is the equation you will get. Let's go to the MATLAB, calculate this. I'm going to put it as S reversible variable is 40 over, bracket open, 1 minus 20 over 80. You get 53.33. kp, yes sir. So we have got all the unknown values. Now we can evaluate what is the number of cycles to failure. N is equal to sigma reversible, which is 53.333 divided by the value of A, We calculate 129.6 raised to the power 1 over b, and remember b is negative, minus 0.0851. 1 over b becomes this. Okay, 1 over b. Okay, so let's calculate. Yeah, if you calculate it, n Goodman, number of cycles to failure, gas reversible over a raised to the power 1 over b. We have calculated a and b initially, a and b. Just calculate the value, and we get, okay, so let's use format long. Just print out NGM value. We get 34,017 and 17.44 cycles to failure. So this is the answer. So let's check if we have the right answer according to the Goodman equation. So this is what we get, that 3.4, so 34,000 cycles. Okay, is this clear?
Yes,
Did
doctor.
you guys? Okay. Okay. So how did you guys do the exam? So we'll stop here. How did you guys do the exam? Can one of you answer? How many of you took your exam already?
Me, doctor.
Okay. Did Jafar take? I think Kasim Ali didn't take.
No,
Mahmoud
yes,
Jafar. Mahmoud Jafar, did you take the exam?
no.
No. Okay. What about Abdul Jalil? Did you take the exam? Mohammed Abdul Jalil. Mohammed Abdul Jalil, did you take the exam? Okay, so he just comes for the attendance sake. He doesn't listen to anything. Okay. Nader, how did you do the exam?
I did fine, doctor, but in a problem two, I stuck in solving the digit diameter.
The diameter. Okay, so you had the problem with the axial load. That is okay. If you came up with the correct equations, then you will get the full score. There is no problem with that. Okay, how about the material indices? Did you solve it?
Yes, doctor. I got e to power 1/2 over
So this is for the plate or hemisphere? Which one you got?
the shell, doctor.
The shell. Okay. Okay. Very good. All right. So we will meet again on Tuesday. Please inform other students if they do not attend the class, they are going to fail the course.
Okay,
And
Richter,
as,
thank you.
yeah. Also inform them, those who have returned empty papers, they are going to fail the course. If they are so irresponsible, they will fail the course. Okay. See you guys, and I will meet you again on Tuesday.
Thank you, doctor.
Welcome.